It is about algebraic expressions. I'm going to say it one more time, and then I'm going to ask you to say it with me. Algebraic expressions. Say it with me. Algebraic expressions. A lot of people have a hard time with that word, so that's how you say it, algebraic. Can I have a volunteer read the learning target where it says LT, please? Swara? Thank you. I just realized this was the given. Oops, that's not what we do. So a little bit of a definition. An algebraic expression is an expression that may contain numbers, operations, and one or more variables. So you guys have been dealing with expressions, numerical expressions, forever. That's just things that have numbers and operations. When it's algebraic, it now involves variables. A variable is a symbol that represents one or more numbers. So you actually have done this before. Like, does anybody remember seeing in elementary school something that might say 3 plus box equals 5, something like that? Yeah. That box is just kind of a way to represent a variable. It's just now, instead of putting a box or a blank spot there, we're going to introduce an actual variable, a symbol. For us, it's going to be a letter. That letter can represent one or more numbers because since we're dealing with expressions don't have equal signs. There's nothing that it's supposed to equal. So that letter, that variable can equal a variety of things. Yeah, thank you. Each number or variable by itself or product of numbers and variables in an algebraic expression is called a term. I know that probably sounds really funky. I think it's easier if I just show you an example and show you what the terms are. So right here, this thing is called an algebraic expression because it's got numbers, operations, and variables. Does anybody know which thing in here is the variable? I need a voice to it. Emma? P. Yeah, so it's a symbol, P, and it represents an unknown number, and it could represent a variety of numbers. We could put like any number we want, right, where that P goes. So this is the expression. The letter is called the variable. The terms are the individual pieces that are being added together. So you can see there's a little plus right there in between these two things. That means there are two terms. There are two things being added together. If we had another like addition symbol and there was another thing after that, that would add a third term. There's three terms. So the terms are the individual pieces. I'm going to circle those and draw like a little arrow and write terms. Just as a reminder, there are two terms in this expression. Now we have two other definitions. The next one is called a coefficient. A coefficient is a number that is directly in front of a variable. So this 5, because it's directly in front of the P, there's no symbol in between them. It says 5P. That 5 is called a coefficient since it comes right before a variable. And then our last definition is a constant. A constant is a number that has no variable. So the 4 in this case, because it's just a plain number. It's constant. It doesn't change. P changes, right? But 4, the number 4, doesn't. So we are going to identify the terms coefficients and constants in each of these expressions to practice. So this is one of the things you have to know how to do from this lesson. Here's our first one, 5x plus 13. Let's start with the terms. How many terms does this expression have? Logan? Correct. Can somebody tell us what the first term of this expression is? We know there's two. What's the first one? Aiden? 5. A little more to the first one. Oh, the 5. Wait, what? There's a little more than 5 for our first term. 5x. 5x, yep. Because a term is any part that's separated by an addition or subtraction symbol. What's the next term? We have the first one. What is the next and last one? Letitia? And next we are going to list the coefficients. Remember, the coefficients are the numbers that are directly in front of, that are connected to a variable. Before we identify the coefficient, what is the variable in this expression? There is only one. What is it? Dash x. Okay, if it's x, what is its coefficient? If x is the variable, what is its coefficient? Reese? 5. And what is the constant? There is one constant in this expression. What is it? Farhan?
13.
Correct, because it's a number all by itself. There's no x, y, z attached to that. Next one, we're going to do the same thing. How many terms does this expression have? Let's start with just how many, so we know how many we're going to have to write down. How many terms does this expression have? Yeah, correct, because there's 3 chunks that are being added together. What is the first term? What would I write down for the very first one? Logan? Correct. So this one we got a little exponent going on, but that's still connected, so it's still part of that first term. What is the second or middle term? Emma?
Y.
And what is the third and last term? Reese?
3.
All right, now we need to identify coefficients. Before we identify coefficients, we got to know what the variables are so we know where to look. How many variables, or what are the variables in this expression? It's different than the first one. Natalie?
2.
Yeah, what are they?
The number 2 and then 2 squared. Or the
What are the variables, the letters?
X and Y.
Z and Y. But yeah, we have 2. We have 2 of them. So that means there should be 2 coefficients. I think a lot of people will really easily get the 2 that's in front of the Z. Here's where it gets a little confusing. There doesn't seem to be a number in front of the Y, but there is. So one other little thing that we need to know about coefficients and variables is when those 2 things are squished together, it means they're being multiplied. So when it says 5x, that means 5 times x. When it says 2z, that means 2 times z. What number could I multiply y by that would not change its value? What can I multiply it by where the answer would just be the same thing, or it wouldn't change? Grayson? 1, meaning there is a coefficient of 1 in front of the y. We're going to write a little note about that over here. We're going to say no coefficient. If we look in front of that letter and we're like, there's nothing there, there actually is an invisible 1, because it means you just have one of them. 1 times y, just 1 y. Whereas here we have 2. Here we have 5. And then our last thing is our constants. There is a constant in this expression. Not all expressions have constants, but this one does. What is the constant in this expression, Farhan?
3.
That's the number that's all alone. It's got no x, y, z attached to it. So an expression is like that whole long string of numbers, operations, variables. The terms are the individual chunks of the expression that are being added together. The variables are the letters. The coefficients are the numbers in front of the variables, in front of the letters that are being multiplied by that letter. And our constants are those constant numbers, the ones that have no letter, no variable, they're not going to change. This just takes a little bit of practice to remember those definitions, but come back to this little picture if you forgot. Second example, example 2, we are now going to do something different, and we are going to write an expression using exponents. We have done this with numbers where the base is a number. Today we're going to do it where the base is a variable. So here I have d times d times d times d. I don't know what d is. D could be a billion different things. How could I rewrite this, though, using an exponent instead to make it shorter? What might that look like, Hayden?
1 times 1 times 1.
That would be, so I see what you're doing. You're changing d into a number. Let's say we don't know what number we want to make it into. How could I just write this as a shorter expression? Still using d, because I don't know what I want to make it yet. Aubrey? Correct. So it's the same thing as having like 2 times 2 times 2 times 2. It's just this time I have a letter. But it doesn't change what I do. I still say I have this thing, d, multiplied by itself 4 times, d to the 4th power. What about this one? I know there's a 1.5 in front, but let's ignore that for now. How about the h times h part? How would I rewrite that piece? Dash?
H to the power 3.
Now remember, if a number that's in front of a variable, if it's right in front of it, it's touching it, there's no symbol, it means they're multiplied. So since 1.5 is being multiplied by this stuff, I can just write it right in front. And that means they're being multiplied together. It's the same thing as up here. If the number's in front of the variable, it means they're multiplied. So since I know these are multiplied, I'm just going to write it right in front of the variable, right in front of the letter. Questions about example 2? This is the same thing as chapter 1, but just now we're using a letter, a variable instead. Now our last section, this is probably the most important section, and this is something you are going to continue to use tons and tons in math. And this is called evaluating an algebraic expression. Evaluate means to find the value of. But how do we find the value of something if we don't know what like x equals? Well, in these examples, you are going to be told what it equals. So to evaluate an algebraic expression, substitute a number for each variable. And they're going to tell you what number to use. They're going to say, hey, x equals 2. Hey, y equals 4. You are going to take out x and y and a and b and whatever you got there, and instead you're going to put in the number they give you. Then you just use GEMDOS to then figure out what it equals. So it's like chapter 1, but this time I have to actually write what the expression looks like with these new numbers in it. So for example, this says evaluate 4n when n equals 12. So they tell us what n equals. Does this mean if I put 12 right there, is this just going to be like 412, or what's happening between the 4 and the n there? Yeah?
4n is 4 times n.
Correct. So when I substitute, when I take out n and put 12 in, I want to make sure in some way I indicate that they're being multiplied and it doesn't just mean 412. I write it like this because this is what you will end up seeing a lot as you move forward in math, like writing it in parentheses. But if you want to actually just write 4 times 12, like with a little x in the middle, that's fine. The reason we don't try not to use x's a lot is because then it gets confusing with the actual letter x, right? It gets like confusing of what's what, but you could do a little dot in between if you want to. That means the value of this expression is 48. When n equals 12, if n were to equal something else, it would have a different value. But if they're telling us that right now n equals 12, that means this expression would equal 48. And over here, you can see another example that they're being multiplied. All right, this one says evaluate a over b when a equals 16 and b equals 2/3. So first I'm going to substitute. I'm going to take out a and write in the number 16. I'm going to take out b and write in the number 2/3. Well, that looks super weird. I have like a fraction within a fraction. Does anybody remember what operation the fraction bar means, what it can indicate? Emma? So I can treat this like it's 16 divided by 2/3. And that might be a little bit easier to figure out. Now I just actually am going to do that, see what it equals. How do I divide fractions? What's that process called that I have to use when dividing fractions? 3 words. 3 words. Swara? So I'm going to keep 16 the same, except I am going to give it a denominator of 1. Change to multiplication, and then I'm going to flip over that second fraction. There is some cross-canceling here. Which 2 numbers here can be cross-canceled? Grayson?
2 and 16.
Yep, 2 goes into 2 once, and into 16 8 times. When I multiply across the top, 8 times 3 is 24, and 1 times 1 is 1. What does 24 over 1 equal? What I want to write as my actual final answer if I got 24 over 1? Farhan?
24.
That means the value of this expression when a equals 16 and b equals 2/3 is 24. Remember, this expression is not always going to equal 24. It just depends what a and b are. But when a and b are these specific numbers, we get 24. Questions about example 4? All right, example 5, evaluate 3x minus 14 when x equals 5. So again, I'm going to start by getting rid of the x and putting in the number I was given, putting in 5. Should I just write 35 minus 14, or what should be happening between the 3 and the 5 if it's like 3x? They're right next to each other. Dash? So I want to in some way write 3 times 5 minus 14. Because remember, this is 3 times x. 3 5s, 3 times 5. But you can write 3 times 5 however you'd like. This one's a little different because I have 2 operations I have to do. So I need to make sure I do it in GEMDAS order. According to GEMDAS, which part of this would I want to do first? Which would be the part I should do first, according to GEMDAS. I'd love to hear from someone I haven't heard from yet today. So we're all thinking. I know you're tired. Do I do the multiplication or the subtraction first, according to GEMDAS? Graham? So 3 times 5 is 15. Then I can subtract the 14 and get 1. That means the value of this expression when x equals 5 is 1. Again, it's only going to equal this when x is 5. If x was a different number, we would get a different answer. And last but not least, evaluate n squared plus 8.5 when n equals 2. So again, I'm going to substitute. I'm going to take out n and put the number 2 in its place. So it says 2 squared plus 8.5. And I need to figure out what this equals. What part do I do first? Do I do the exponents or the addition first? According to GEMDAS, exponents or addition? I would again love to hear someone I haven't heard from yet today. Which comes first in GEMDAS, exponents or addition? Lizandra?
Exponents.
So 2 squared, it means 2 times 2 or 4. And then I add the 8.5 and I get 12.5. So the value of this expression when n equals 2 is 12.5. Again, only when n equals 2. If n was something different, I'll get a different answer.